Welcome, everyone. I'm Sarah Conway from Sneak, in charge of partner marketing. Thank you very much for joining us today. We have a really exciting DevSecOps session planned for you today, where we're going to look at migrating your containerized apps to the AWS Cloud Platform. We're really excited to welcome two of our great partners with James Bland from AWS. We'll be talking about the history of web architectures, which is AWS's legacy. We'll also talk with Angel Rivera, who's a developer advocate at Circle CI. He's going to walk through the value of the Circle CI org and where Circle CI fits in the tool chain. And then finally, we're going to wrap things up with Jay Uras. He is a cloud and cloud native solutions architect at Sneak, and he's going to walk through a demo and show us how secure coding and CI/CD easily go hand in hand. Just a few housekeeping items. We do have a recording that will be made available afterward. We are accepting questions at any time throughout the session, but we're going to save the actual answering and the live Q&A part to the end. And then also for anyone who might have joined and is interested in the AirPods, we will be emailing out the winner after this session, whoever won that the free AirPods. So with that, I'm going to turn it over to James, and he's going to set the stage for us by walking through the AWS context.
Thanks, Sarah. Hello, everyone, and thanks for joining today's presentation on the DevSecOps journey, migrating your containerized applications to the AWS Cloud Platform. For today's presentation, we have myself, James Bland, a Senior Partner Solutions Architect with AWS, Angel Rivera, a Developer Advocate with Circle CI, and Jay Uras, Head of Cloud Solutions Architecture at SNIG. In today's presentation, we're going to cover the following topics. First, an abbreviated version of the Amazon story and how we gain speed and agility to innovate faster. Because it's an abbreviated story, I'm going to provide some additional ways you can learn more about AWS. Then, Angel from Circle CI is going to present how you can leverage their platform to migrate workloads to AWS and develop faster. After Angel, we're going to hear from Jay Uras and do a deep dive into SNIC's security solutions. Lastly, we're going to leave a little time on the end for Q&A, but feel free to ask questions in the chat as we go along. At AWS, we provide customers with the broadest and deepest cloud platform. AWS has more services and more capabilities within each service than any other cloud provider. With AWS, customers can get the right tools for the job they want to get done. We deliver innovation to customers at the fastest pace. In 2011, we released over 80 new significant services and features, followed nearly 160 in 2012, 280 in 2013, 516 in 2014, 722 in 2015, 1017 in 2016, 1040, 430 in 2017, and 1957 in 2018. We have the most mature cloud platform. There's no compression algorithm for experience, especially when it comes to scale, security, and performance. So how did we get here? Starting out, this is what Amazon's web architecture looked like. Nothing too fancy, a web server, a database, all in a remote facility. This design presents many different bottlenecks, and scaling of the web servers was an immediate factor. Fast forward to around circa 1998, when we began to break things down into separate components. To scale the web server, we improved the original design by adding web databases to alleviate the bottleneck of accessing a single database. This design was better, but still not very scalable and presents a different set of challenges. To go further, we knew we had to change. So we came up with 4 principles that would help us transform into the company we are today. First, make units as small as possible. It is easier to reason about the impact of changes when systems are small. Large and complex systems are inherently problematic to changes, and it's nearly impossible to map out all the dependencies and interdependencies that exist. Second, decouple based on scaling factors, not functions. What this means is to think about the different factors that affect scaling. So when thinking of a 3-tier app, it's almost natural to think about decoupling each different tier, but you would fall into the trap of decoupling based on functions such as web, application, and database. Decoupling based on factors means we might decouple that 3-tier app into authentication and identity, shopping cart, storefront, and order processing, which allows us to scale each service based on usage of the service and not function of the components. Third, each service operates independently. This means no release schedule and no other service to encumber deployments of features and functionality. And fourth, APIs between services. This principle enables the 3 other principles by having services expose themselves via an API. API adds a layer of abstraction, and one service consuming resources from another service does not need to be concerned with the implementation details. Culturally, this led to the 2-pizza team. A 2-pizza team is one in which each team is made up of no more people than can be fed by 2 pizzas. This keeps team sizes small enough to not impact communications, but also forces teams to be creative in how they deal with scale and the service which they operate. At AWS, our 2-pizza teams are autonomous to make decisions and work directly with customers. They are empowered to develop and launch based on what they learn from interactions with customers. We iterate products continuously, and the newest and latest is instantly available to customers. No need to upgrade, deploy, or migrate. When a feature enhancement is ready, we push it out, and it is instantly available to any customer that uses that service. What you'll see on this slide is a typical monolithic development lifecycle. A large team of developers, a single small monolithic service, and a single delivery pipeline. A lot of different bottlenecks here. Developers have to pay attention to the details of the implementation to avoid impacting the service. This usually means lots of meetings to discuss the change, lots of testing to ensure no other components break due to changes, and single-threaded delivery pipelines that are on a release schedule. All in all, you have a really slow and fragile software development lifecycle. Now we have the changes necessary for the 4 principles mentioned earlier. First, we break the developers down into the 2-pizza teams. Next, we break the services down based on scaling factors, aka monolithic services. Then we give each team their own individual delivery pipeline so they can release at their own pace and not have to be encumbered by the release cycles of other services or teams. This developmental shift has had a positive impact into our ability to innovate at high speeds and scale. Fast forward to today. This is a picture of the different microservices at AWS and how they are interconnected. So the 4 principles, the 2-pizza teams, and the development-enabled pipelines is part of what allowed AWS to scale to build more services and more features within those services than any other cloud provider. There are 5 reasons companies are moving so quickly to the AWS cloud. The first is agility. AWS lets customers quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. This means they can very quickly develop and roll out new applications, and it means teams can experiment and innovate more quickly and frequently. If an experiment fails, you can always deprovision those servers without risk. The second reason is cost savings. If you look at how people end up moving to the cloud, almost always the conversation starter ends up being cost. AWS allows customers to trade capital expense for variable expense, paying for IT as they consume it. And the variable expense is much lower than what customers can do for themselves because of AWS's economies of scale. For example, Dow Jones has estimated that migrating its data centers to AWS will contribute to a global savings of $100 million in infrastructure costs. The third reason is elasticity. Customers used to over-provision to ensure they had enough capacity to handle their business operations at the peak level of activity. Now, they can provision the amount of resources that they actually need. knowing they can instantly scale up or down along with the needs of their business, which also reduces costs and improves the customer's ability to meet their users' demands. The fourth reason is the cloud allows customers to innovate faster because they can focus their highly available IT resources on developing applications that differentiate their business and transform customer experiences instead of the undifferentiated heavy lifting of managing infrastructure and data centers. The fifth reason is that AWS enables customers to deploy globally in minutes. AWS has the concept of a region, which is a physical location around the world where we cluster data centers. We call each group of logical data centers an availability zone. Using AWS, customers can leverage 73 availability zones across 23 geographic regions worldwide, and we don't plan to stop there. As I mentioned earlier, this was only an abbreviated history of Amazon and AWS. If you want to learn more, check out the Amazon Builders Library, which is a collection of living articles and videos that give readers a look under the hood at how Amazon builds and operates the technologies that underpin Amazon.com and AWS. The Builders Library content is written by senior technical executives and engineers who are responsible for that topic on a daily basis, and drives deep into the real-world practices used by Amazon every day. Also, be sure to check out AWS modernization workshops. At awsworkshop.io, you'll find a collection of workshops that cover topics around modernization. The workshops provide a hands-on approach to modernizing various aspects of your business and what technology will drive this change. Now I'm going to turn things over to Angel at Circle CI. Hello, Angel.
Hi, James. Thank you so much. I want to welcome everyone to my portion of the talk. So next slide, please. Let's talk about Circle CI. Basically, what Circle CI's mission is to provide a platform for developers to build, test, and deploy their code using automation. And to kind of piggyback on what James was saying, help our customers deliver their code consistently, reliably, and most of all, quickly. Next slide. So before we get into a little bit about the Circle CI product, I wanted to introduce the company. It's been around since 2011, and the two other takeaways I wanted you to recognize here were we had in 2017 the company had rebuilt the platform from its previous version 1, and we launched Circle CI 2.0. This was a complete rebuild of the platform. And the reason why we did that was the previous platform, was kind of built in the era or the beginnings of the cloud native kind of revolution. And we wanted to provide some, features that would lend itself better to a cloud native experience. And by doing so, we added a couple things. One of the keynote features that we added was the ability to run your builds in a Docker runtime environment. And the other advancement that we made was adding this concept of configurable parameterized YAML. So that was basically launched the product that we call Orbs. The other piece I want you to recognize as well on this slide is that currently we do over 1 million builds per day on our platform for our customers and users. Next slide. So this diagram illustrates how Circle CI sits in a kind of developer toolchain. It's a continuous integration, continuous delivery deployment platform. So if you look at the creation layer or side of this diagram, that tends to deal with more of the continuous integration portions, right? When you're developing code, when you're making changes to code, how that interaction in regards to continuous integration occurs within your teams. And then if you move over to the run or the deployment kind of setup, the logistics side, that deals with more of getting the application out into production environments or target environments that is intended to run these applications. And if you look at center stage, Circle CI is there in between both of those worlds, right? Orchestrating all those processes for our customers. Next slide, please. So this is a nice diagram as well to kind of show the iterative process, right? Circle CI is intended to provide fast feedback loops so that developers know when their code is having issues or their bugs exist or it's not behaving as intended. We want to be able to have the developer, you know, kind of follow their optimal workflow, which is write some code, push it up to maybe version control, GitHub, Bitbucket, whatever. And then Circle CI is monitoring for changes. Once it detects the changes, it will then go ahead and run a predefined pipeline. And once those pipelines are run, the developer gets you know, really quick feedback loop, meaning, you know, having notified of any problems, if any. If you have a happy path, right, and everything's clean and green, you can just move on to building the next feature in your software or going on to the next task in your list. Next slide. So what I discussed earlier was a feature that we created, having you know, been with Circle CI since 2018. This Orbs product had or feature had been launched, and prior to it, developers would write their code in YAML, right? And of course, YAML is a data structure, declarative data structure that's commonly used throughout the cloud native ecosystem. And the issue with YAML, though, is that it's a data structure, but it does not allow for any kind of you know, functional operations. So you can't have any if statements or any kind of logic. But what we've done at Circle CI is we've recognized that our customers and users needed some sort of functionality to parameterize the values within YAML. Prior to this Orb launch, our customers were cut and pasting functionality, right? And a lot of times it was just cut and pasting, and the only difference was a variable or a value, right? One value. So imagine if you're cut and pasting functionality 100 times over because of one value, now you have a really complex and voluminous YAML. So the configuration for our customers were getting unmanageable, right, unmaintainable. And that's where kind of Orbs comes into play, is it gives you the ability to parameterize that YAML now. And it gives you that ability also to kind of encapsulate certain functionality or patterns. And that also lends itself to code reusability, right? So now because of that reusability, your YAML can become a lot shorter because you're just you know, implementing the calls that you need from one location. Next slide, please. So this is a nice visual of what kind of an orb is. To the right, you have a YAML. Now, this is the actual the orb as far as behind the scenes, right? So if I'm showing you is how you can create an orb or the code behind an orb. Orbs are open sourced so that companies, teams, project or users, open source projects can write their own orbs. And once they write their orbs, it's listed in a registry, which I'll show you in a little bit. But basically what's going on here is this is a simple Hello World app. And one of the things or a couple things I wanted to display here is there's 3 elements to an orb. And the first element is a commands element, which is basically parameterized sets of execution commands that you can run, right? So for instance, down there in the commands, we have a run hello world, right? So that just echoes a hello world message with a parameterized to value. The second is the executors element, right? So the executors is the actual runtime. So this basically describes where you want to run your code. We have currently have 4 different types of executors. The default is generally Docker. Then we have a virtual machine executor. which can run, Linux for the most part. We also have a Mac OS, iOS runtime, and then we have just recently added Windows runtime. So now we basically covered all of the major runtimes or operating systems, so that folks can, jump in between their different requirements for runtimes. And then finally, we have the jobs element, which is a grouping of all of the commands, right? So jobs are generally described as a block of executions that need to occur in a certain manner. Next slide. This is an example of an orb in use. So what I showed you previously was kind of behind the scenes, under the covers orb. This is actually an example of how to implement an orb in a Circle CI pipeline. One thing to note there is, as you can see, underneath that version 2.1 line, you have an orbs key. And what I'm showing you here is an AWS Elastic Container Registry orb. So what that does is you have that functionality in the CLI, in the AWS CLI, you can actually just, cleanly implement that functionality. And if you look at the workflows key there, right underneath that is, in a few lines, is an AWS ECR build and push image command. So that's how you would implement an orb within your configuration pipeline. Now, previous to that, we would have, you would have to kind of write out all the CLI commands that you wanted to activate or execute within your pipeline, and then cut and paste, right, multiple times. If you had a couple, maybe you were doing, 10, building 10 images in one shot for different runtimes, you would have to cut and paste that. So with having this orbs capability, that cuts down on a lot of the volume within the configuration file, and it also gives it a nice maintainable aspect to it as well, without having to kind of scroll through hundreds and thousands of lines of config, which in some cases does happen with some of our users and customers. Next slide. So again, if you're interested in writing orbs, they are open sourced. So it's a program that you can just go in. You can actually do this on your own. We have documentation on our site. Once you do that, we have 3 different types of orbs. One is partner certified, and then of course a community, what we call community. So if you would be starting out, writing an orb, you would probably start as a community, and then there are no paid tiers or anything. Again, it's just open source. And one of the other things I wanted to mention was you can see here we have some partners that have written orbs. So imagine, our partner Snyk and AWS, they have orbs in our ecosystem. So if you're an AWS user or a Snyk user, and you wanted to implement, a scan of security scan, or you wanted to deploy your code to ECR or EKS or whatever in AWS, then you can just easily grab that, the kind of the work's already been pre-baked for you. You just need to populate the values for the target environments you want to use your orb against. And I believe that is all for me. I want to now transition over to Jay from Snyk, so he can educate us and show us an awesome demo on Snyk.
Thanks, Angel, and thanks to all the attendees for your time and interest in this topic. So my name is Jay, and I wanted to kind of guide everybody through an example of how we're going to leverage these terrific synergies between AWS and Circle CI, and then also implement Snyk to secure our development process. So, earlier when James was talking about the Amazon way, or the story of AWS, one key component there, if you might have picked up, was really around enablement of teams. And we have that, and we have the extensibility and flexibility of Circle CI. And through these exercises, hopefully I'll be able to illustrate how all these things come together to help you succeed. Snyk. All right. So I wanted to give you guys a little bit more than just me speaking. So what you have here is a free self-paced workshop. that I created, and I will provide details on where you can obtain this or where you can go to complete this. So this workshop is really going to cover all the topics that I'm going to mention today. And regardless of your skill level, I assure you, I will be with you 100% of the way and walk you through this in painstaking detail. So if you're a seasoned veteran, I guarantee you there'll be something in there that you'll probably find that you didn't know before. And if you're new, no worries. You'll have step-by-step examples that you could do at your leisure that will guide you through this workflow. And what that workflow is going to consist of is taking a sample application and then deploying that to a Kubernetes cluster running on EKS. And then along the way, I'll share some insights on how you can improve your security posture by implementing several integrations that Snyk has to offer, as well as the Snyk orb and a couple of best practices around your development process. So Snyk. With all these workshops, I want to raise the bar a little bit further, and I'm not just going to provide content that is easy to consume, but I'm also going to provide a public GitHub repository that's going to contain some sample code, some templates. So that will be available to you as part of that workshop. No need to copy and paste the link there. It's all included in that workshop link that I'll provide later on. But what I'd like to do then is talk a little bit more about what's contained in these exercises. Snyk. All right, so the workshop flow is going to consist, as I mentioned, of creating an EKS cluster. We're going to start with that. Obviously, you'll need an AWS account in order to do that. We're going to go through the process of cloning that sample Git repository that I shared as part of that workshop. We'll apply some best practices and we'll create an AWS IAM user and generate some keys and a secret for that we'll use to interact with our AWS environment. And we're also going to create a Circle CI account. And if you already have one, terrific. We can configure that. If you don't, then sign up for one. It's also free. And we're going to configure our Circle project. In doing so, we're going to declare a couple of environment variables within Circle CI to alleviate having to pass any compromising information over clear. And then we're going to enable some Snyk integrations, deploy our application. Then we're going to find some vulnerabilities. What's in our code? And then I have some homework for you. We'll leave you with some action items to go ahead and take some of the lessons learned and then apply some fixes and see what you come up with. Snyk. Terrific. So there's several different ways that you could deploy EKS. If you already have a running cluster, that's fine. You can use that, or you can find alternative ways to deploy this. There's an AWS Quick Start for EKS that simplifies this process in a one-click deployment. And Snyk actually just launched a Snyk version of this that deploys the Snyk controller to monitor your workloads running on EKS just yesterday. So you'll find some terrific announcements around that. But sticking to the topic at hand, the creation of this EKS cluster as part of these exercises is going to take shape through just some basic CLI commands. We're going to use EKS CTL to provision a sample cluster. Again, I have instructions on exactly how to do that as part of this workshop. So what you see here is just the results of what you would expect to see once your cluster has been provisioned. You can simply apply the respective command line to just validate that your services are up and running. Snyk. So I mentioned before that we were going to do some configurations on our Circle CI project. And this is really simple. The workflow is really as simple as cloning that GitHub repository, and then from your Circle CI account, enabling that project. Now, what we will do there as well is after we've created those secrets and the keys for your IAM user, we're going to pass in those as environment variables. So we'll go into our project settings and we'll fill those out. And again, no need to worry about this. I'm explaining what's in the workshop content, and there'll be more detail in that workshop. Snyk. Excellent. So I want to take a step. I mentioned that there was a GitHub repository, and that GitHub repository had some sample templates, some sample code, and so forth. One critical component for any Circle CI project is there needs to be a Circle CI config file. And this is a config.yaml file that my friend Angel here was going into some details on what this consists of. So I want to take a moment to kind of walk you through the elements of that config.yaml file. Now, for the purposes of this webinar, I've taken the liberty of trimming these a little bit just to make it easier to read. Again, the GitHub repository has the complete config.yaml. And then in my workshop, I break it down with much more details into what it is that I'm including. Angel also mentioned some certified and partner orbs that are available. So for my particular use case, since I'm running my workloads on AWS and I want to take advantage of the depth and breadth of those services and high availability and all that fun stuff that we all depend on for our critical applications, I've selected two AWS specific orbs. These are ECR and EKS, and I've also selected a Kubernetes orb as well to apply some commands to my cluster. And these are all certified orbs. And of course, I'm including my partner orb, Snyk, because what I want to do is also build some application scanning and container image scanning as part of my build process when my pipeline runs. Snyk. So what does that look like? Again, I've trimmed down that config file. Here's another section of that config file. Angel mentioned this concept of jobs within the config file. I have a job is included in here where I'm basically doing an application scan using that Snyk orb. This simplifies this process tremendously. Rather than having multiple lines in a file, I really just concatenate that to one basic line of just calling that Snyk orb. And then passing a couple of other parameters. So I've, again, taken the liberty to highlight in red some of the more pertinent ones. These were options that I made. So for example, I'm setting my severity threshold to high. You have the option of adjusting this as you see fit, as well as other parameters. But in this case, just for the demonstration, I wanted to just focus on those high severities that I may have in my application. And then, of course, I'm pointing to a specific target file, which has, all the listing of my dependencies for my application. So for this example, we're using an application that we've provided to the public called Goof. This is, as you can probably deduce from the package.json, a Node app. And what it does is it's a simple to-do application consisting of a web front end and then a back end running on MongoDB. Snyk. All right, the second portion of my config file is going to include scanning of my container image. Now, this is really about migrations and how you can secure your workloads as you're considering modernizing your application. So this example, as minimal as it may be, is meant to illustrate some steps that you can start taking today. We all have been there. We have legacy code applications. Now we're faced with a project that we're going to migrate. We don't quite know what we have. We may not be actively monitoring for some of these dependencies, and who knows, we may have forgotten. It might have been an old project. But by incorporating these very simple techniques into your development flow, you're now able to create some actionable insights that you can take advantage of in order to remedy some of these situations. So in this application, I mentioned it's a Node app. What I'm doing as part of my build process, however, is I'm also going to containerize this. So I'm going to create a container image off of my Goof app, which I'm later going to push to ECR. But part of that process is really going to involve scanning that container image. How and why? Well, the why part, let's take that first. We've already identified what vulnerabilities exist in my application code in the previous job, but we don't know what vulnerabilities may exist in the base images that I'm using as part of this container. So for that, as we build our container image from a Docker file, we're going to go ahead and perform a scan on that so that we can bring those to light and get some actionable insights. And again, similar to the previous example, I went ahead and took some liberties and highlighted in red some relevant areas. Like, for example, the fact that we're going to be consuming a Docker file as part of this build process, as well as what that tag is going to be for my Docker image that we're passing through as part of our workflow. And then again, I'm really interested in the high severity one, so I've just gone ahead and tagged that accordingly. Great. So we finally built our image, we've scanned it. Now we move on to the next part of our Circle config, and this is where we're going to push our image to ECR. Now this is a terrific orb. I have a couple of settings here that I've enabled. First of which is creating a repo and having that repo created with the name of my Circle project. Terrific. But that create repo true that I've highlighted there. If you already have a repo that matches that repo name, it'll just simply update your image. But if you don't, it'll create one for you. Talk about simplicity. I don't have to go to the AWS console, which I love, but I simplify the process through a couple of command lines, so I don't have to take that extra step and make my workflow a little bit more efficient. Sneak. Great. Now we're ready for the last part of this, right? Which is really when we're now going to deploy this application. Now, for that, again, in the GitHub repository, I've included a couple of templates for you. And these are Kubernetes manifests that are going to provision my application, both as a deployment as well as a service. Now, what I'm doing here in Circle is not only applying those manifests to my Kubernetes cluster on EKS, but I'm also doing some fancy things like replacing the Docker image name with the path for my container image that I just built from my Circle pipeline and substituting that. That way, when the manifest is applied, it's going to pull the appropriate image, and it's going to pull that from my private registry on ECR with that fresh image that I've scanned. Now, hopefully at this point, you're starting to see a couple of redundancies in this, and I'll explain that in a little bit. Sneak. So once my pipeline is triggered, it's really a simple process. As Angel pointed out, you get feedback right away on what's going on as part of that process. So here you'll see an example of what that pipeline will look like in your environment as it's actually running. You could see some of the jobs that have been defined, for example, testing the application, where I just do a basic functional test of npm install to make sure that it's actually running and correct. And then we proceed on to the next step where we scan the app. Then we do a build and scan of the application, and then we push it and so forth, right? So super easy to use, very streamlined and pretty powerful and extensible. Again, Sneak. Terrific. So our application has deployed successfully. The command should be really familiar. This time, however, we're going to see that we have some additional information because, as I mentioned before, we've just deployed our Goof app to our Kubernetes cluster, and that consisted of a two-tier application. We have a front end, and we also have a back end. So what you're seeing here is the external IP of our front end, which has been deployed as a load balancer. Now, we're going to use that information later on. And in my workshop, I have a couple of techniques that I'm going to show on how you can pass those values in through the command line to do some additional stuff, operations on that application. But you can take that and you can copy that over to a web browser, and then it will render what that application will look like. Sneak. And here's an example of that. So I mentioned this Goof app is a to-do app. It's actually the best to-do app ever. This application is going to now be up and running and able for you to interact. And it's, we'll go through a couple of the examples of what we were able to discover as part of our scanning and how it all comes together with our various integrations. And then what I'd like to do then is kind of show you what some of these vulnerabilities actually mean in terms of an application that's out in the wild and the potential risks that those can expose you to. Sneak. Okay, so earlier on, I had a slide that was part of the workshop, and I wanted to kind of pop that out a little bit and talk a little bit about what's to come. So we have here a couple of different, simplified stages of what's going to be our development flow. We obviously have our code in the source somewhere. We're going to leverage Circle CI/CD to do the building of that application, the container image, pushing that out to ECR, and then deploying to a Kubernetes cluster. And then we're going to monitor with Snyk. But the thing is, we're not going to just monitor with Snyk at the very end. We're going to include our various integrations to SCMs like GitHub, integrations to ECR, integrations to EKS, and obviously with Circle CI as well, to really cover our bases. Every step of the way, we're going to iterate through, and we're going to provide visibility into every step of that process. And the reason for that is we want to be able to capture as much as possible any out-of-band changes that could take place from existing monitored resources from a developer potentially doing a feature branch out and having some content in their repository, provided that they're using the Snyk orb and all of these other integration points. Again, we're building that safety net to really have some consistency in how we're monitoring for these potential vulnerabilities, not just point in time, but also as new changes may be introduced into your workflows as a result of working on a project or a feature enhancement or fixing a bug and so forth. Snyk. So what does this look like from the Snyk perspective? You have here a quick screen grab, and I'm going to go through a series of these that are going to map to that previous diagram that I shared with you. And these are really based on some of these integrations that I mentioned before. So this source code that's available in GitHub. So we have, Snyk has a GitHub integration, and I've enabled this. So what you see here is an actual scan of that goof app. So I've taken a look at that package.json, and I see you might be a little bit obscure, but there's about 26 high severity vulnerabilities that were found in this application. So let's take a look at some of the others. Snyk. Now, we included another scan within our Circle config, and that scan was another application scan. And what you're seeing here is the product of that. Once that application scan took place in Circle, it wasn't just some transient results. We actually are going to leverage Snyk's APIs, and we're going to post those results back as a project within our Snyk account. So we're able to correlate these again and be able to capture any deviations that may have happened. But again, in this case, I didn't make any modifications, so it's consistent. I still have 26 high sev vulnerabilities, and we're still monitoring that same package.json for our goof app. Let's look at the next one, Snyk. All right, terrific. What we see here now is our integration to ECR. So part of this process included taking that application, containerizing it, and then pushing it to ECR. But I've also enabled this integration as well, because what I want to see is any subsequent images that might be pushed to my repository, whether it be by myself or any other folks on my team. And the interesting thing here, as I mentioned before, is you want to have actionable insights on what vulnerabilities are there with something reasonable for you to be able to fix. We have a huge conversation that everybody's talking about shifting left, and that's terrific, but we don't want to put the burden of having to become security experts to our developers. So at Snyk, what we've done, being developer first as we are, is we've mitigated this for you by making very simple decisions. So in this case, we're taking a look at that base image that is being used as part of this application, and we're listing that. That's your current image. These are the vulnerabilities that you have. In our case, we have about 726 vulnerabilities in that base image. We're giving you an actionable item there. We're giving you a recommendation for how you should upgrade that to mitigate that and reduce some of those vulns. So we have a base recommendation of changing this from a Node 6 to a Node 10 image, and that brings us down to 656 total vulnerabilities and just 16 high sevs. So again, it isn't about having expectations that you're going to be able to solve everything, but at least having the awareness of and having an acceptance of risk of what you are potentially deploying to your environment. That's critical here. Snyk. So the second part of this too, we have a really interesting integration with Kubernetes. We talked a lot about application security. We talked a lot about the container image scanning, but it often gets forgotten that basic configurations or misconfigurations of Kubernetes can also be critical and negatively impact your business. So our Kubernetes integration takes advantage of this by being able to surface some of these potential misconfigurations. So again, in this example, I'm intentionally deploying an application with a lot of bad things that we want to fix. And what you see on the screen here is that Kubernetes integration showing that I've made some mistakes. And in my Kubernetes manifest, I forgot to include some basic limits around CPU and memory utilization for my app. I'm allowing my container to run as root. I'm also running it with all Linux capabilities. And these are very simple things that can be included as part of a security context, inclusion of security context and having some of these parameters set within your Kubernetes configuration. So again, give you that comprehensive story of securing your workload end to end. Sneak. So I promised that I was going to talk a little bit about what these vulnerabilities mean. And terrific, Jay, you've shown us how great Sneak can surface these vulnerabilities, but why should I care? Obviously, I could respond and say, we don't want to be in the press for something negative. We want our companies to be in the press for positive things. So I'm going to cherry pick a couple of vulnerabilities that are in this sample application and kind of demonstrate what the impact of this would be. So I'm selecting a few of these. Again, this is a Node application, so these are NPM packages. Some of the vulnerabilities that popped up here were marked. Another one is MS, and another one is ST. And as you can see with MS, for example, it's dependent on separate vulnerability that we had with a separate package, Humanize. But at any rate, these serve specific functions in our application, and I'm going to kind of walk you through a little bit what these are doing and how it plays out with a potential bad actor. Sneak. Okay, so let's start with marked. So actually, let's start with SD. Forgive me. So one of the things about our application once you run it is that there's a really cool little about thing at the bottom, and that's a very common thing for most applications. You'll have an about page that's kind of static. The interesting thing there is that potential bad actors, will once they start noticing that there's some static pages, they might get curious and might want to start taking a look at what else they can do. Now, fortunately, if you're doing this from a modern web browser, there are some guardrails in place to prevent you from really exploiting systems that way. However, Sneak. If we do this from the command line, it's a different story. So the example that you see here is, again, with that ST vulnerability, which is really around directory traversal. So these are some screen grabs of me on the command line doing a couple things. I've passed in the value for my load balancer that's running my front end application, and then I'm doing a simple curl command on that same about page. The interesting thing there is that I can now escape out. Now I can do .. and this will capture it and won't allow me to do that. But if I substitute that with the HTML encoded version of .. now I'm able to back out of that directory where that about.html page is hosted. And what I'm doing in these exercises is doing that, but also navigating to, guess what, my Etsy directory. And what else can I do from there? Well, now I can start basically displaying the contents of files. So here's the directory listing, as I mentioned before, and then I'm also able to look at group, for example, and see additional information. Now we can go on and then look at other things like password and stuff like that. So obviously this is not something you want. So that's clearly one that needs to get mitigated ASAP, right? And then again, this is a very crude example, but one that kind of illustrates where that vulnerability would potentially impact your business. Sneak. Okay, the next part of this really is with the marked package. So what does that do for us? This is a to-do app. The basic flow for this app is literally just type in something in the field and then it creates little reminders for you. But because it has support for Markdown, I can do some fancy things like, bolding some words. I might even be able to, add some links to my to-do items, and this one I'm choosing to, let's put a reminder for myself to evaluate Sneak. Why not? That's a good idea. You should probably all do that. But it also opens the doors to some other more potential things. that are not advantageous for you, and it goes beyond just the markdown. So we can mark down and provide that link to a URL, but what can we also do? We can provide a link to some JavaScript, and that's kind of where our exploit comes in. Sneak. So this is going to exploit the vulnerability in Marked to do some cross-site scripting, as I mentioned. So this screen grab right here is a very benign one. All I did was create a reminder for myself, gotcha, which I wouldn't be doing. Some bad actor would be doing this because they were able to access, you know, from the command line, my public-facing page and pass some of these values along. So I just simply had a very simple link with some JavaScript to just give me an alert, right? A very basic example, very benign, but obviously opens the door to some more sophisticated attacks that someone who is using this application would unwittingly click on a link, and then some other potentially compromising situations could happen. So again, really important one that we want to secure this. Sneak. All right, terrific. The last vulnerability that I wanted to talk about is with the MS package. Now, this is often used in a number of different applications, and as you can see from the flow in this screen grab, what I'm doing here is basically taking some string inputs and then converting this into some milliseconds to give me some reminders. So I really should apply updates to my servers. I should do that in about 30 minutes or so, and that's you know, that's pretty much the extent of that. Now, where does the vulnerability come in? The vulnerability comes in with what's called regular expression denial of service attacks. So I'll show you that in a minute here. Sneak. Now, what this does here, I'm not going to apply this command that you see here on the left right now. But I want to talk about it a little bit. What this will do is basically set reminders. Again, I'm using the command line in order to drive this. And what I'm doing is setting a reminder for myself, and I'm actually going to try and exploit this a little bit more. And I'm adding this reminder repeatedly for, you know, a bunch of times, but where it comes in is now with a mismatch. I've purposely misspelled minutes into, you know, what you see on the screen here. The result of applying this to your current application running on this EKS cluster is that it will become unresponsive. It'll stop accepting response. So obviously basic premise of any denial of service attacks, and we were able to exploit this by passing a regular expression to that from the command line. So again, you know, these are some examples of very critical things. I mentioned we had about 26 different vulnerabilities that were high sev. I chose 3 examples. You know, I challenge you to take a look at what's in your applications as well and see what you can come up with. Now, I mentioned that some of these vulnerabilities can be easily solved when you're leveraging Sneak, not just to have visibility into what they are, but also, we don't talk about it here, but I talk about it in the workshop. Sneak offers developers this concept of automated pull requests. So once vulnerabilities are found, and you see those complex dependency trees, you know, with you know, different vulnerabilities, we take the guesswork and the logic out of the equation by providing an automated PR to your source that will solve for any identified vulnerabilities that are found, provided that there's fixes for those. Sneak. Awesome. So we're at the tail end of this, and I kind of wanted to quickly recap what we covered today. So, you know, the points that I wanted to get across is that the introducing security into your workflow need not be a huge technical feat for you. We're making it super simple. We have terrific partners like AWS and the tremendous services that are available there. We have terrific partners like CircleCI that provide us so many capabilities to be able to deploy our applications in a seamless fashion. And now you have, you know, Sneak orbs that you can incorporate into those workflows to secure that. So hopefully these examples show you some general gists of how you can secure your pipeline end to end, as well as monitoring potential configuration drifts that might expose you to some of these potential attacks. And again, by using Sneak, not only do you get those insights, but you have the ability to automatically fix these before that problem is surfaced. So I promised you a link for the workshop, and then I'll be done here. Sneak. You can visit https://solutions.snyk.io, and you'll see the content of everything that I've covered here in those easy to use step-by-step examples. And with that, I will pause for some Q&A.
Great. So if anyone has any questions, feel free to chime in with them. You can drop them in the chat window there. One question that came through, let's see. Do I need Docker file for the Snyk to scan my Docker image, or provide only ready Docker image is enough? Or is providing an only ready Docker image enough?
Yeah, I see that. I'll take that question. So, Patrick, so today the examples that I provided include linking a Docker file from your source code to get that base image recommendation. You don't need the Docker file in order to do the initial scan of the image. We can do that without that file and then provide your results on what vulnerabilities would exist. Once you link the file, however, you do get base image recommendations provided to you. I don't know if it's available yet, but I believe that in the near future, that will be optional, and we'll be able to provide base image recommendations without the Docker file. So hopefully that answered your question.
Great. I think another question is coming in. I will be sending out a recording after this session, so it will probably come tomorrow morning. So everyone will get that, those who attended and those who didn't. And I don't know if, Angel, do you want to tell us a little bit about how easy it is to develop with an orb and getting started with one? And, you know, for folks that might want to check that out, that would be great.
Yeah, so again, orbs are open source. So yeah, you can go to the Circle CI / I believe it's orbs page, or you can do a quick Google search for Circle CI orbs. And we do have a starter orb, actually. So we use our own technology to get people started. I believe they call it the Orb Starter Kit, and that can be found on GitHub. But you know, the actual code, yeah, and it's a pretty easy entry point to get started. But for the most part, yeah, just Circle CI orbs /orbs should get you where you need to be. And then there's plenty of documentation as well in our doc site. We also have a forum site that provides our Circle CI community a place to kind of collaborate and share tricks, tips, and solutions to problems people are experiencing. And also you can collaborate, or we also message like events and, you know, put posts up there for things that are up and coming.
Great. And then one question came in, sort of the difference between Circle CI and GitHub Actions, if you want to take that one too, Angel.
Yeah, so Circle CI basically is, the difference is we interact with multiple version control systems, whereas GitHub's Actions is, you know, kind of vendor lock-in built into their platform. So we've been around a lot longer, so we have a lot more intel and experience in the CI/CD space, and we have a lot more options as well and flexibility with the features that we have in the product. So one of the other pieces or benefits of Circle CI is we're really, really fast. So yeah.
Great. And then Jay, we have a request to make the slides available too. Can we add that to the workshop on the Solutions Snyk page?
Yeah, absolutely. Happy to provide a link for that.
Yeah, then we can have both the slides and the recording that will be sent out afterward. Let me see here. I think those are does this work with chef recipes too? There's another question that came through.
I could help field that. So if you're talking about Circle CI, yes, you can implement Chef within your pipelines, and anything you can do, you know, with the Chef CLI, you can implement within Circle CI as well. And I believe, You can also run scans if you're building, Docker files or your application. You can leverage Snyk and obviously AWS and all of those.
I want to take one more question from Patrick real quick before we're out of time. I see that he asked whether Snyk is cloud-based or on-premise. So what I've shown today is really around our SaaS offering, and that actually consists of two products. There's Snyk Open Source that does the application scanning of open source dependencies, and then there's Snyk Container that does the container image scanning. We do have a free tier, so there's no commitments or anything like that. You can sign up for an account and then test things out yourself. There is an on-premises solution that we offer called Snyk Broker. That can be leveraged in conjunction with your Snyk account if you wanted to have some workloads running, whether they're on premises in the data center or anywhere else. So, and again, all this information is available off of our site as well. All right, folks, I think Sarah might have been on mute, but thank you all for attending. Again, I hope you found the content inspiring and insightful. And again, appreciate your time. Please visit the workshop and please provide feedback as well. Thanks all. Happy coding.
Take care.